Okay, let's look at the other section from chapter 9, which is linear regression. Now, there's actually not all that much new in here computation-wise. So we've talked about using regression for prediction. So in the previous class, we talked about R, the correlation coefficient, which tells us how strong the correlation is, how close to linear it is. So what we'll do is confirm that we have linear correlation, and then we can construct the regression line in order to make predictions. So in this diagram, these blue dots are data points that we have. The line is what we call the regression line or best fit line. We're going to come up with the equation of this line and we'll use it to make predictions. Residuals is not something you'll need to worry about for this class. The calculator is going to do all of this for us. So in the equation of a line, we have y equals mx plus b. X is our variable, y is our predicted variable. So what we're going to do is take data, we'll run it through the calculator so that we can get m, the slope, b, the y-intercept. Now, don't be scared by this long, complicated formula. We're not going to do any of this. The calculator will do this all very quickly. So let's look at this data set that we were looking at in the previous class. What we're going to do is put this data in the calculator. We'll run linear regression like we did in the previous class to get R, and that will give us the regression line. So on the calculator, just like we did the other day, go to lists and input the data. No, not on the list. There we go. And list 2. Okay, and again, make sure that all of your data points are paired. If you have any extra values, it won't run the regression. So just quit back to the home screen. Hit Stat, arrow over to Calculate. We want linear regression, which is option 4. Tell it list 1 and list 2. Some of your calculators will have a menu here instead, and they'll say X and Y, and you'll want to put L1 into X and L2 into Y. Enter. Y equals AX plus B, which is similar to Y equals MX plus B. This is just the way our calculator uses to express this. So on the calculator screen, we have A equals 199.5, B equals 56. And then we simply plug those numbers into the format. Y equals 199.5x plus 56. And that is the equation of the regression line. So in this case, X represents GDP, or gross domestic product. Y represents the amount of CO2. So we're bypassing this long, nasty formula here, and we have the regression equation. Okay, so here we're looking at old faithful data. we would do the exact same thing here. Just be careful. There are 4 columns, but there's only 2 variables. So if you're going to do this in the calculator, make sure you have all the x's as a single list and then all the y's as a single list. Here they're showing us different ways to use technology. Here's on the TI-84 like we just did. Now, what we can do is make predictions with this equation. So they're saying, all right, what if the GDP is $1.2 trillion? We already have the formula we need. We simply take this 1.2 and plug it into the equation. So we know that y equals CO2, x equals GDP. We simply plug in the 1.2. Calculator will do this if we ask nicely. 295.4. And this is the amount of CO2 corresponding to a GDP of 1.2 trillion. So it's that easy. We simply plug in 1.2 for x in the equation and calculate y. And then I have 2 more examples of that here. And that's it. That's how we get the regression equation and use it for prediction.